Now we're going to take a look at horizontal stretch. So first of all, we're going to look at f of x is equal to the quantity 1/2 x squared. We've already looked at b values bigger than 1, or absolute value of b bigger than 1. What about if they're fractions that are less than 1? So let's go ahead and graph f of x equals quantity 1/2 x squared. Alright, so here we have f of x equals x squared. Let's make b equal to 1/2, which would be 0.5. What happened? The new graph is actually wider than the parent graph. And that's why we call it horizontal stretching. It becomes wider than the original. The original parent graph is here. The new graph is here. Let's look at another example. Sine. Okay. Let's go back to b equals 1. If we make b equal to 1/2, which is 0.5, it takes that original parent graph and it stretches it out. Just like a string. If you were to grab this string on the left and on the right and pull on it, that's exactly what would happen. It would stretch out. Let's look at one more example. I guess cosine. It's basically the same thing. Instead of compressing like we did before, when you make b a fraction, it stretches out from the original parent graph. Okay, I'm not going to harp on that much more. Obviously, you can see that these fractions cause stretches. But why? We can see that when b is equal to 1/2, the parent graph stretches horizontally by a factor of 2. Okay, but why? So it actually does do by a factor of 2. We can see that with our quadratic function. P of 1 is equal to 1. In order to achieve the same y value, we have to multiply that x by 2. P of 3 is equal to 9. To get the same x value over here, we've got to take this x value, multiply it by 2. So 3 times 2 is 6, and that gives you 9. So when b is 1/2, it's stretched by 2. So why? So just like I showed before, p of 1 is 1 because 1 squared is 1. But since we have a 1/2 here, in order for the y value to be 1, the input has to be 1, so this must be equal to 1. So we'd have to multiply 1/2 by 2. Or in other words, 2 times 1, the original x value, 1. The halves will cancel, and 1 times 1 is 1, and 1 squared is 1. Therefore, the original x value was multiplied by 2 to achieve the same y value. Therefore, the horizontal stretch is 2. Okay, what about for 3? Well, p of 3 is equal to 9, as we just showed on the graph here. You can see p of 3 is 9. Why does f of 6 equal 9? Or how do we get that algebraically? Well, again, you're going to have to take this original x value and multiply it by 2 to cancel out this 1/2 we put in front of the x for our b value, because that will ensure that our input is still 3 and we get the same y value back of 9. Another way to show this is, since p of 3 is equal to 9, we want these two inputs to be the same so that we get 9 back no matter what. So set 3 equal to 1/2 x. And now you can see that in order to get the same x value back, you must divide, to get your transformed x value, you must divide both sides by 1/2. Now let's read this little blurb I have right here. With both horizontal stretch and shrink, you do divide by b, the coefficient of x. So the rule is the same as when we did horizontal shrinking. Now another thing you could do is multiply both sides by 2. I like to keep it that way, so it's just easy to remember to divide by b, but by all means multiply by the reciprocal. That's how fractions work when you divide them. So you're going to take 3 and end up multiplying by 2. Now you can see why it stretches by 2, right? Because you're multiplying by the reciprocal of this fraction to get your new x value of 6. So your transformed x value is 6. Now whether or not, okay, I need to change. Okay, sorry about that, folks. I had to fix that. So if I plug in 6 for f, I'm going to get the same values. If I plug in 3 for p, I'm going to get 9 either way, and that's because 6 is just 2 times 3. I'm taking the original x value and I'm multiplying it by 2 to ensure that the 2 times 2 cancels that 1 over 2 that I originally had for my b value up here. And therefore, we get the same y value of 9. This is what it looks like on the chart. P of x is equal to x squared. We've looked at this hundreds of times already, it seems like. But since b is 1/2, again, I did say this. It's the same rule as the last horizontal shrinking. You take the original x values and you still divide by b, but sometimes it's helpful to see that you're actually multiplying by the reciprocal, because the times 2 actually shows you that stretch. You know, you're seeing that the parent graph is stretching out by a factor of 2 to reach this wider transformed f of x graph. So our new x values, negative 2 times 2 is negative 4, negative 1 times 2 is negative 2, and so on and so forth. We're going to keep the same y values. But you can see those x values get multiplied by a factor of 2, and here is our transformed function without changing the y values. All we've done is multiply the original x values, negative 2, negative 1, 0, 1, 2, by 2, and that gives us a chart that we can then graph for f of x equals 1/2 of x squared. That's it for this video of horizontal stretching when b is equal to 1/2. If you have any questions about it, let me know.